Question 10. A particle is moving in simple harmonic motion. The displacement of the particle is x and its velocity, v, is given by the equation v squared equals n squared times 2kx minus x squared in brackets, where n and k are constants. The particle is initially at x equals k. Which function, in terms of time t, could represent the motion of the particle? Let's start with the velocity equation v squared equals n squared times 2kx minus x squared in brackets. Now we can use this equation to find the displacements when the particle's velocity is equal to 0. And we do that by solving the equation v squared equals 0. So to solve v squared equals 0, we solve 2kx minus x squared equals 0 since n is non-zero, which means that the only way that v or v squared can equal 0 is if what's inside the brackets is equal to 0. So solving 2kx minus x squared equals 0, we factorize out x on the left-hand side, so we get x outside of 2k minus x in brackets equals 0, which means that v or v squared is equal to 0 when x is equal to 0 and x equals 2k. Now if we consider the graph of v with respect to x, if n equals k, we end up with a circle centered on the x-axis at x equals k, and the velocity of the particle is 0 at the origin and at x equals 2k. Now if n does not equal k, we end up with a vertically oriented ellipse or an oval centered on the x-axis at x equals k, and the velocities are still 0 at the origin and at x equals 2k. Now the velocity is maximum here and here. In other words, the maximum and minimum velocities occur at x equals k. And I've written that here. So the absolute value of the velocity or the speed of the particle is maximum at x equals k. And that occurs at time t equals 0. So let's find the velocity when x equals k. So when x equals k, v squared is equal to n squared outside of 2k squared minus k squared in brackets. Collecting the like terms, we get v squared is equal to n squared k squared. And then taking the square root of both sides, we get v is equal to plus or minus nk. If we go back to our graph, positive nk will correspond to this point here, and negative nk will correspond to this point here. Now by inspection, if we consider option B, that's x equals k times sine nt plus k, and differentiate x with respect to t, we get v is equal to nk times cos nt. Substituting t equals 0 here, we get v is equal to nk times cos of 0, and cos of 0 is equal to 1, which means v is equal to nk, which is one of the solutions that we got here. Now all other options will not give v equals either plus or minus nk when differentiated at time t equals 0. Therefore the correct answer is option B.